Let's take a look at a couple of examples of how the discriminant can help us just see if there's an answer or not. You throw a ball toward a friend in a window, 15 feet off the ground, on the upper floor of your house. You throw the ball with the initial velocity of 35 feet per second from a height of 6 feet. Will the ball reach the window? For a problem like this, we need to remember our vertical motion models. If we're dropping an object, then we have h equals negative 16t squared plus s, where s is our initial height. But if we're throwing it, we're going to use this one here. Height equals negative 16 times t squared, t is our time, plus our initial velocity times time, plus the initial height. Okay, so for the first one here, let's use that formula. Actually, we're going to use it for both, so I'll just write it up here. Okay, so we're throwing it with an initial velocity of 35 feet per second. I'm going to put that in for V, and from a height of 6 feet. So that's our initial height, and I'll put that in for S. And we want to know, will the ball reach the window? Well, the window's 15 feet off the ground, so we're going to put that in for H. So we're 15 feet off the ground. Now, we want to know, is it going to reach the window? Well, if we set this equal to 0 and put it in standard form, we end up with a quadratic equation. And if we want to know if it's going to reach the window, we're not saying how long is it going to take to reach the window. We're just saying, is it going to reach the window? We want to know if there's a solution, a real solution. And if we want to know if there's a real solution, we can use our discriminant. Again, it's not asking us what the solution is. It's asking us, is there a solution? Will it reach the window? So we take our quadratic equation in standard form and plug it into our discriminant here. We have 35 squared minus 4 times a negative 16 times negative 9. And we get an answer of 649. So what does that answer mean? It's positive. If the answer, when you evaluate the discriminant, is positive, that means it has two real solutions. So is it going to reach the window? Yes. Yes, it will, because our discriminant is positive, meaning it has two real solutions. Let's look at this example. Let's do the same thing, but this time you're throwing it with an initial velocity of 20 feet. You're still starting from a height of 6, and the window is still 15 feet off the ground. So if we plug that information into our vertical motion model, okay, put it in standard form, set it equal to 0. Again, that tells us if there's solutions. We need y to be 0, because then our solutions will hit the x-axis. Hold on one second. Okay, sorry about the interruption, but anyway, as we continue this problem, if we subtract negative 15 off of each side, we get 0 equals negative 16 times t squared plus 35t plus a negative 9. So now looking at this, if we want to know, will it reach the window? Not how long it takes to reach the window, just yes or no. We want to know if there's a solution. So let's use our discriminant again. If we plug our numbers into our discriminant, we get 20 squared, because that's our, I'm sorry, and I used 35 again. So sorry guys, let me fix that. Actually, let's do this. Okay, using our new information here and our vertical motion model, we're going to say we want to know if it's going to reach a window 15 feet up. We have negative 16 t squared plus our initial velocity of 20 times t plus our initial height of 6. Subtracting 15 off of each side, we end up with 0 equals negative 16 t squared plus 20t plus negative 9. Now we can use our discriminant. 20 squared minus 4 times a negative 16 times a negative 9. When you calculate that, you get an answer of a negative 176. What does it mean to have a negative discriminant? It means there's no real solutions. So is the ball going to reach the window? No, because there are no real number solutions to this problem. So the discriminant can be helpful when we're not actually looking for a solution. If we just want to know, is there a solution? The discriminant can tell us that answer.